Teo, please. Okay. All right, so starting with what we know, let's start with the area of a rectangle. You know how to find the area of a rectangle. So how do you find the area of a rectangle? How do you find the area of a rectangle? Whoa. Base times height. Area of a rectangle is just base times height. So let's take that rectangle and use it to talk about the area of a parallelogram. So notice this parallelogram has base labeled B and height labeled H. Well, this is a parallelogram, but notice what happens if I take this chunk and bring it over here. It becomes a rectangle. You already know that the area of a rectangle is base times height, so doesn't it make sense that the area of this parallelogram will also be base times height? Let's consider a triangle. If I take, for example, this triangle and put another one just like it right next to it, what do I have now? And it's not a rectangle, it's a parallelogram. And we already talked about how the area of a parallelogram is base times height. So my question to you is, what fraction of this parallelogram is our original triangle? 1/2. So that's where that 1/2 comes from in the area of a triangle being 1/2 base times height. And a point was brought up in an earlier class. Let's benefit from that. One of my students said, isn't that the same as base times height divided by 2? And I said, absolutely. So if the neurons work better thinking along the lines of base times height divided by 2 instead of 1/2 base times height, run with that. I, however, want to make sure that I'm giving you the formulas the way that you'll see them on that reference sheet. Okay? So in problem 1, we are simply finding the area of the parallelogram. The formula again is base times height. So in that parallelogram, do I have everything I need so that I can just plug the values into the formula? Yes or no? Yes. Area equals, my base is 8, my height is 7, and the area is 56 square centimeters. Okay, something I want to make sure I make a big deal about. Remember that when you take quizzes in my class, they are not multiple choice. Tests are. So the quiz that you'll take next week will be an open response. If you forget to write down the square units, you will lose 1/2 point. That doesn't sound like a lot, but it'd be a real shame to lose a whole lot of those 1/2 points. Don't do that to yourself. Sorry. I don't know. 8 times. Get what?
Oh, I used to like.
Good. Okay, same exact question for part B. You're finding the area of it. Again, the first thing I want you to ask yourself is, do we know everything we need in order to plug it into the formula? Do I know the base and height? Yes. The 12 is my base and the 5 is my height. Question? A good question. The base in a parallelogram is always one of its sides. The height is basically the perpendicular distance between those bases. No, it doesn't matter. Good question. All right, so area equals 12 times 5, which is 60. Again, don't forget your units. 60 square inches. Quentin, also remember that in a parallelogram, those two sides are congruent anyway. So if I know this is 12, I know the bottom one is 12 also. Okay? Yes, the parallelogram. Okay, good here? Pretty easy. There's a your turn just like it. If my screen would work. There we And it is a Centio question, so when you have found the area of the figure, please key it in. I'm pretty sure there's more than 16 of us in here. Make sure that you've logged into your Centio. Ooh, those answers are coming in fast. Oh my gosh, this is tough. This is ridiculous. In today's lesson, all we're doing is parallelograms and triangles. Once again, when you have found your answer, please key it into the Centio. And fantastic. All you're doing is multiplying the base and height. 12 times 9 is 108. If I had to guess what went wrong for that 96, someone just forgot their times tables. It happens. Good on the screen? Okay. The next problem is not so much difficult as much as the diagram just looks really busy. So understand what's happening in this diagram. The question that Quentin brought up is kind of coming into play here. Remember that when we're finding the area, the base and height have to be perpendicular. So what base do I know that I also have a perpendicular height for? Remember my answer to Quentin's question about how do I know which one is the base? The base is always a side of the parallelogram. So which side of the parallelogram, the 12 or the 9, do I know the length of the perpendicular segment for? The 9, yes. I know this 10 that's perpendicular to it. So I can use that to find the area. So area equals 9 times 10, which is 90. But the problem is asking me for the length of DF. Realize what DF is. DF is the height for the other base. What you need to realize is that it doesn't matter which base and height I'm using. The area stays the same. So that 90 equals the other base times the other height. Well, the other base is 12, so 90 equals 12 times, and I'm trying to figure out what the height is. Now you're just solving an equation by dividing both sides by 12. Because notice, the problem is asking us for the length of this segment. Do you see that that is the perpendicular height between the 12s? Yes? It's the segment perpendicular to the 12. You see that one? Okay. So the 12 would be the base because it's still a side of the parallelogram. The height that corresponds to it is what I'm trying to find, and that's the h in my equation. And when we solve for that, we get that h is 7.5 centimeters. And once again, you can benefit from my having heard questions that other students asked already. Question asked earlier this morning was, Mrs. Clouse, how come that one isn't square centimeters? Can someone answer that question? Why isn't this one square centimeters? One person, please don't call out Mr. Massey. Exactly. When we're finding area, that's in square units. This is just the length of a segment. Good on the screen. We have a your turn just like it, and it is also a Centio question. And when you have answered it, please key it into your Centio. Yes, ma'am. again, this is a Centio question. When you found your answer, please put it in. Areas parallel.
What you're doing by doing it times this and side times that. That when you go from 7, I put it down to this base, is this one. If they parallelogram, this one. That's what you say.
Okay, in the interest of clearing up some confusion, I'm going to stop this question in another 20 seconds. So those of you that have an answer, have enough time to input it. Those of you that are still kind of, I don't like this problem. You just, kind of waiting for me to get moving on this. I think this is easier without the diagram than with it. Some of you tried to draw a diagram like what you saw in problem 2, and I think you made your life harder than it needed to be. Okay, so the good news is that those of you that did answer in your Centio, overwhelmingly, the majority did get the correct answer. As far as what did you do to get the 30, I can't think what you did. But let me show you what you should have done. As I mentioned earlier, I think it's a lot easier without the diagram if you're reading it carefully, especially if you start reading that second sentence. That second sentence says that the height corresponding to the 15 centimeter base is 9. Remember how you find area. It's base times height. So that's why the first thing I did is multiply that 15 times 9 to find the area. Once again, the area is the same no matter which base and height you're using. So if I take that 135 that is my area and I plug into it the 18 centimeter base, now I'm solving for h. By dividing both sides by that 18, and interestingly enough, we get the same answer that we got for the problem 2, but the numbers were a little bit different in the middle. Is there confusion still on this kind of problem? Okay. So that's parallelograms. In problem 3, we're looking at a triangle. Remember, formula for the area of a triangle is just 1/2 base times height. So I read the problem. It says the brace, the triangular brace, is 3 inches high and 2.2 inches wide. So again, my question to you is, do I have every piece of information that I need in order to just plug into the formula, yes or no? Yes, I know the base, it's that width. I know the height, it's the 3. I'm just plugging numbers into my calculator. 1/2 times 2.2 times 3 will give me 3.3 square inches. Once again, something I overheard, something I was asked, Mrs. Clouse, is it half of the base and then times the height, or is it half of the whole thing? It doesn't matter, it's the same exact thing. Think of it as just 3 numbers being multiplied together. 1/2 times the base times the height. If it makes your heart happier, think of that 1/2 as a 0.5 that you're just typing into your calculator. You have what we need from this screen? Okay, the next question is also a Centio question. Notice that the instructions on the screen add the statement round to the nearest square inch. What you want to remember is that base and height have to be perpendicular. Not necessarily. I just wanted to make sure to specify what unit I want to use. Okay. Thank you for self-control. There's no rounding necessarily, but I wanted to specify what unit I wanted the answer in. We're still waiting for a couple of you to key your answers in. I'll wait another 30 seconds before I stop the question. I'm stopping the question. There's no penalty if you didn't get a chance to enter your answer. And there it is. It was kind of a close call between 30 and 3. And I'm guessing the 3 came from people not realizing the difference between the feet and the inches, and you did 5 times 1. And took a half of that and got 2.5 and rounded that to 3. And I love hearing students sometimes. This morning while my students were working on this, one of my students was like, "Where do you see a 12? And he's getting all riled up at his classmate trying to tell him 12 times 5. Where do you see the 12? The 1 foot. Okay, so that's why you had to do 12 times 5 and then take half of that in order to get 30. Okay? Still good? All right. The problem 4, rather than it being a problem I worked through on the screen, I think confident you can handle this within your group, and then we'll address it together. Find the area of the figure. It is not a Centio question. We are done with Centios. If you want to go ahead and turn those off. Beautiful. Okay, from what I'm seeing and hearing, you're about ready for us to talk about this together. The area of the rectangle, of course, is base times height. Looking at it carefully, what two numbers am I multiplying together here? The 5 times 12. So the area of the rectangle is 60 square centimeters. For the area of the triangle, what is the base of that triangle? It's 5, and the height of it is 4. So we have 1/2 times 5 times 4, giving us 10 square centimeters for the triangle, which means the total is 70 square centimeters.
How do you get the board?
Fantastic question. If this whole thing is 16, and this part of it is 12, what's left? 4. Okay? And then the last question in your notes is asking, what if I double the base of the rectangle and the base of the triangle, but I leave the heights alone? How will the area of the whole figure be affected? Alex, what do you think? Okay, what about the rectangles? Well, no, if I'm doubling the base of the rectangle also, it will also double, which means the area of the whole thing will just double. But be careful. If I were to double all of the measurements, it would quadruple. We'll get more into that on Friday's lesson as far as why it's quadrupled. Don't go crazy making yourself insane about it. But as far as this is concerned, the area would be doubled. And I do have a daily quiz on Socrative. Give me a moment to activate it.